Welcome to all students of class 12. In this class, you are going to learn to solve the system of linear equation by matrix method. In the previous class, all students have been learned the inverse of the matrix, and inverse of the matrix is defined by existing adjoint of the matrix. Hence, we know that in the previous class, if A is a matrix and determinant A is the corresponding determinant of the matrix, and then A inverse is equal to 1 by determinant of A into adjoint A. It is the rule of the finding inverse of the matrix, and according to this rule, the inverse has been exist in the previous classes. In this class, we have to find to solve the system of linear equation. Since system of linear equation are given here, the shown system of linear equation, it depends on the three variables. In this equation, there are three variables x, y, and z. Hence, we have to find the rule for solving this equation or equation of this pattern. Suppose that a1x b1y c1z equal to d1 is equation first. a2x b2x plus b2y plus c2z is equal to d2, it is equation second. And a3x plus b3y plus c3z equal to d3, it is equation third. If the three equation is given, now we have to find a corresponding matrix of the equation. Equation is since corresponding matrix of this equation are given by all the coefficients of the variables, and its variables is, suppose that matrix A, and this matrix A is written as matrix A, and this matrix A will be equal to A1, B1, and C1. Second row A2, B2, and C2. Third row A3, B3, and C3. It is a matrix A. And again, we find a matrix of variable, and this matrix is denoted by X. The X is X, Y, and Z. It is matrix second. And the third matrix is made by the constant of the equation. The constant of first equation is d1, constant of second equation is d2, constant of third equation is d3, and it is represented by matrix B. The matrix B is d1, d2, and d3. d1, d2, and d3 is a matrix. First of all, we have to find inverse of this matrix. For this, to find the inverse of the matrix, first of all, we have to find corresponding determinant of this matrix. We know that if inverse of the matrix is equal to 1 by into determinant A into adjoint of matrix A. Adjoint of matrix A can be exist by finding the factor of the corresponding determinant. And if we find A inverse of this matrix A, then now we have to find the value of X, and hence Ax equal to B, and hence X equal to A inverse into B. If we find X equal to A inverse into B, then by the equating the LHS and RHS matrix, and we can find the value of variables. If we see that if determinant A is 0, if in this equation means the equation of finding A inverse, if A inverse equal to 1 by determinant A into adjoint A, and in this equation, in this condition, if determinant A is equal to 0, then the inverse is not real, inverse is not existed, because if determinant A it is equal to 0, then its inverse cannot be exist, because therefore A inverse will be equal to if we find determinant A equal to 0, then A inverse will be 1 by 0 into adjoint of A, and we know that 1 by 0 equal to infinity. Therefore, A inverse cannot exist. If A inverse is not exist, then we cannot find the value of x. Means we cannot solve this equation. And hence we have to necessarily for determinant A is not equal to 0. If determinant A is not equal to 0, then we can find the value of this equation, and this type of equation is said to be consistent and consistent. And this consistent equation is also known as consistent or unique solution. Means in this condition, in this situation, equation has a unique solution. And but in this condition, if determinant A does not equal to 0, then equation has consistent and it has unique solution. Means for unique solution it is necessary to determinant A does not equal to 0. If the determinant is equal to 0 and but adjoint A into B does not equal to 0, then the system is called inconsistent, and it is inconsistent and it has no any solution. If determinant A is equal to 0 and adjoint of A into B it is not equal to it is equal to 0 and it is not equal to 0, then equation means system of equation is inconsistent. It is inconsistent and it has no solution. Means in this condition equation has no any solution. And the third condition is that, and if determinant A will be equal to 0, and adjoint of A into B it is also 0. Means determinant A equal to 0 and adjoint A into B it is 0, then the equation means system of equation is consistent 0, then equation means system of equation is consistent for infinity solution. Infinite solution means infinite solution. Means the system of equation has many solutions and all solutions are different. In this situation, equation has only equation has unique solution. Means there are x, y, for x, y and z there exists only one value. Means one value for x, one value of x, y and one value of z. In this situation, inconsistent and it has no solution, then the equation has no any solution. And in this situation, the equation is consistent for infinity solution. Means x has infinitely many solution, y has also infinitely many solution, and z has also infinitely many solution. Now we can solve a equation of two variable. Equation on the two variable. Suppose that a system of equation are given. Suppose that system of equation is given that 2x plus 5y it is equal to 7 and 6x plus 15y it is also equal to 13. It is equation first and it is equation second. Means the equation first and second are given and we have to find this equation. Sorry, we have to solve this equation by matrix method. First of all, we form a matrix by coefficient of the variable 2 and 5, 6 and 15. Now x it is equal to x and y and a matrix made from constant of the equation 7 and 13. Since constant of this equation is 7 and constant of equation second is 13, then the matrix B is 7 and 13. The coefficient of x in equation first is 2 and coefficient of y is 5. Therefore, first row of this matrix is 2 and 5. And in the second equation, the coefficient of x equal to 6 and coefficient of y equal to 15. Then its second row is 6 and 15. First of all, we have to find determinant A. Means determinant A is equal to 2, 5 and 6, 15. The value of 15 into 2 equal to 30 and 15 into 2 30 and 6 into 5 it is also 30 equal to 0. Since determinant A it is equal to 0. Now we have to find the system will be inconsistent if adjoint B into B is not equal to 0 or adjoint B. Now we have to find adjoint of B. Since A11 of this matrix means cofactor of the matrix can be existed. Since cofactor of A11 is equal to -1 to the power 1 plus 1 and its first row common row left, then the only 15 it is equal to 15. A12 -1 to the power 1 plus 2 1 2 and it is -6. It is 6 and -1 into 6 means -6. A1 2 1 it is equal to -1 to the power 2 plus 1 and its corresponding element is 5. It is equal to -5 and A22 it is equal to -1 to the power 2 plus 2 means the corresponding element of the second row of second column. It is equal to 2 means 2. Therefore, matrix made by cofactor it is equal to 15 -6 -5 and 2 Hence adjoint of A, it is equal to 15 minus 6 and minus 5 and 2. It is adjoint. Now we have to find adjoint of A into matrix B. Now adjoint of A into matrix B, it is equal to 15 and minus 5 and minus 6 and 2. And matrix B is given that 7 and 13. If we find this 15 into 7, 105 minus 5 into 13, it is equal to minus 5 into 13 minus 65. And for second row, minus 6 into 7, minus 6 into 7 is equal to 42, sorry, minus 42, and it is plus 15 into 30 plus 13 into 2, 13 into 2 means 26. It is equal to minus 105 and 65, 105. It is equal to 40 and it is equal to minus 16, minus 16. It is not equal to 0. Hence, we can see that the product of adjoint A and B is not equal to 0. And we know that hence determinant A is equal to 0 and adjoint of A into B means product of adjoint A and B is not equal to 0, then equation is inconsistent and it has no solution. This situation shows in this problem. In this problem, determinant A equal to 0 and product of adjoint A into B means product of adjoint A and B is also does not equal to 0. Hence the equation means system of equation is inconsistent, and it has no any solution. The next question. The next problem is given on the board. In this problem, matrix A is given and we have to find A inverse, and hence we have to solve the system of this equation. Means by using A inverse we have to solve the system of equation. Here three equations are in the system and all the three equations are based on the three variables x, y and z. To solve this equation, the corresponding determinant A made by this equation is 1, 2 and minus 3. 2, 3 and 2. 3, minus 3 and minus 4. Means the coefficient of all variables made from this matrix, and this matrix is shown in this problem. Then we can easily solve this problem by matrix method. First of all, we have to find the corresponding determinant of this matrix. Solution. Corresponding determinant A, it is equal to 1, 2, minus 3, 2, 3, 2 and 3, minus 3, minus 4. And the value of determinant can be found 1, 3, 2 and minus 3, minus 4. Minus 2 and 2, 2, 3, minus 4. And minus 3 and 2, 3, 3, minus 3. And it is equal to 1 into minus 12 minus plus 6 minus 2 minus 8 minus 6 minus 3 into minus -6 or -9. It is equal to -12 plus 6, it is equal to -6, and -2 into -14 -3 into -15, and it is equal to -6 plus 28 and plus 45. 45 plus 28 is equal to 5 plus 3 and 4 plus 2 6 means 7 minus 6. 750 minus 6 is equal to 67. Means the value of determinant is 67. Value of this determinant is 67. Hence, the matrix A is invertible. Now we can adjust the inverse of this matrix. For finding the inverse of this matrix, first of all we have to find the corresponding cofactor. Cofactor A11 can be written by -1 to the power 1 plus 1 into matrix 3 2 and -3 -4. It is equal to 1 and into -12 minus plus 6, and it is equal to -6. A12 it is equal to -1 to the power 1 plus 2 1 plus 2. Then corresponding determinant 2 and 3 minus 4. 2 2 3 minus 4, and it is equal to -1 and into -8 minus 6, and it is equal to -14 into -1, it is equal to 14. A13 it is equal to -1 to the power 1 plus 3, and its corresponding determinant is 2 3 and 3 minus 3. 2 3 3 minus 3, and it is equal to 1 and into -6 minus 9, and it is equal to -15. A21 is from second row. A21 it is equal to -1 to the power 2 plus 1, and its corresponding determinant is 2 minus 3 minus 3 minus 4. 2 minus 3 and -3 minus 4, and it is equal to -1 into -8 and plus 9, and it is equal to -1. A22 it is equal to -1 to the power 2 plus 2, and it is equal to its corresponding determinant from 2 to 1 minus 3 and 3 minus 4. 1 minus 3 and 3 minus 4, it is equal to 1, and it is equal to -4, and minus plus 9, and it is equal to 5. A23 it is equal to -1 to the power 2 plus 3, and corresponding determinant 1 2 and 3 minus 3. 1 2 and 3 minus 3, it is equal to -1 into -3 minus 5 means 8. -3 minus 6 means 9. -9 into -1 is 9. Here 2 3 1 minus 1 to the power 3 plus 1, and its corresponding determinant is 2 minus 3 and 3 2, and it is equal to 1 and 4 minus plus 9 means 13. A32 it is equal to -1 to the power 3 plus 2, and its corresponding determinant 1 minus 3 1 minus 3, and 2 2 minus 1 into 2 minus plus 6 means -8. A33 it is equal to -1 to the power 3 plus 3 means corresponding determinant 1 2 and 2 3. It is equal to 1 into 3 minus 4, it is -1. Then matrix by cofactor is can be achieved by finding the transpose of the matrix made by cofactors. Therefore, adjoint A is. Therefore, A inverse it is equal to 1 by determinant A into adjoint of matrix A, and it is equal to 1 by 67. 67 into matrix minus 6 minus 1 and 13. 14, 5 and minus 8 and minus 15, 9 and minus 1. A inverse is exists. Now, the matrix X is equal to X, Y and Z, and matrix B will be equal to minus 4, 2 and 11. Now, we have to find X. Since X equal to A inverse into B, X is equal to X, Y and Z, and A inverse 1 by 67 into minus 6, minus 1 and 13, 14, 5 and minus 8 and minus 15, 9 and minus 1. It is A inverse, and B is minus 4, 2 and 11. This implies it is equal to 1 by 67 into minus 6, 4. 6 for that 24 plus minus 1 into 2 means minus 2. 13 into 11. 13 into 11 will be equal to 141. 13 into 11. Yes. 13 into 11 is equal to 201. It is equal to 13 into 11. Sorry. 13, 11 is equal to 13, 143. It is equal to 143, and it is equal to plus 143 in the second row. 64 into minus 14 into minus 4, 50 minus 56, 5 to jar plus 10 and minus 88. Minus 15 into 4 means 60, 9 into 2 plus 18 and minus 1 into 11 means minus 11, and it is equal to 1 by 67 into matrix 143 plus 24, 143 plus 24, it is equal to this and this. Then we can find that 124 plus 43 means 7 and 4, that's 7, 4, 3, 7, 4, 2, 6 and 1, 167 minus 2, and it is equal to minus 56 minus 38, 8 plus 6, 4 minus 4 and 8, 5 minus 13 and minus 14, minus 144 plus 10, and it is equal to 18 plus 6, 78 minus 11, and it is equal to 1 by 67, and it is equal to 165 and minus 134, and it is 78 minus 11 is 67. It is equal to 165 by 7. It is 2 and minus 2 and it is 1. It is equal to 3, and hence X, Y, Z, it is equal to 165 by 7 minus 2 and 1. Therefore, X equal to 165 by 7 equal to -2 and z equal to 1. It is answer and it is the solution of this equation. Thank you for this class. Now in next class.